Hello my dear friends, how are you all? I hope you all are fine. So my dear friends, you are very welcome in a lecture number 3 of triangles, okay? Yes, so I hope you will enjoy this lecture. So without wasting the time, let's start. Yeah, so today we are going to continue our previous topic, criteria for congruence of triangles. Okay, in previous lecture we learned about the side angle side rules. Okay, this was the axioms, but now here we are going to discuss about the theorem 7.1, which is angle side angle congruence rule. This is a theorem, so this theorem need to be proved. Okay, so what is this theorem? So now two triangles are congruent. Two triangles are congruent if two angles and the included side of one triangle, two angles and the included side of one triangle are equal, are equal to two angles and the included side of the other triangles. Okay, so this is what this is angle side angle rule. Okay, means two angles of one triangle and there is one side which is included between these two angles is equal to the two angles and the included sides. Okay, two angles and the included side of these triangles. Okay, so I hope you get this point my dear friends. So according to this statement, here is triangle ABC is congruent to triangle DEF by what? By angle side angle rule. Okay my dear friends, I hope you get this point. So we have to prove this condition. Okay, we have to prove this condition. So first of all we have to write the given part. The given part will be, we know that in triangle ABC and triangle DEF, okay, angle B is equals to angle E and angle C is equals to angle F. This is the given part, and BC is equals to EF. Okay, we have this given part and we have to prove this condition. So how we can prove this? So we will prove by considering the following cases. We will prove this condition by considering the following cases. Now let's suppose, now in the case 1, okay, here is, let, we are assuming that AB is equals to DE. Okay, what is, yeah, this side AB is equals to DE. Okay, so in triangle ABC and triangle DEF, okay, AB is equals to DE. This is assumed. Okay, and angle B is equals to angle E. Okay, this is given, means this angle is equals to this angle. Okay, and BC is equals to what? BC is equals to EF. This is also given. So from this we can write here as triangle ABC is congruent to triangle DEF. Congruent to triangle DEF by what? By side angle side rule. By side angle side rule. By side angle side congruence rule. I hope you understand these things. Okay, so this is the case 1. Now let's come on the second case. Now in this case we are doing a construction. Okay, so take a point P on AB. We are taking point P on AB such that PB PB is equals to DE. Okay, and we are joining P to E, P to C. Okay, so here is, take a point P on AB such that PB is equals to DE. PB is equals to DE. So in triangle PBDE, BC and triangle DEF. Okay, PB is equals to DE. Okay, this is again assumed. This is what? This is again assumed. Okay, and angle B is equals to angle E. So this is given. Similarly, BC is equals to EF. This is also given. This is also given. So we can say that triangle PBC is congruent to triangle DEF by side angle side rule. Here is this. Here is one side and this is corresponding sides and the angle and this angle, and again we have this side and we have this side. So two sides and one angle between the two sides. So this is what? Side angle side rule. Okay, now from this we can write here as, now angle PCB, this angle is equals to angle DEF by CPCT, corresponding parts of congruent triangle. So here is angle PCB is equals to angle DFE. They are equal by CPCT. Okay, if any two triangles are congruent, then all the corresponding sides and corresponding angles are equal to each other. Okay, so here is these angles no need to be proved because they are corresponding parts of congruent triangle. So now here is, you can observe this, but we know that but angle ACB is equals to DFE. This is given. Okay, but angle AEB is equals to angle DEF. So this is not possible. So means angle PCB is not equals to angle DFE. This is only possible when this point P coincide on A. Okay, my dear friends. So here is, we can say that thus angle ACB is equals to angle PCB. Okay, so this is possible. This is possible only if P is coincides with A. If P is coincide with A, so AB is equals to DE. AB is equals to what? DE. Okay, so here is, this will become AB is equals to DE. So as similar to the case 1, we can prove that angle triangle ABC is similar to triangle DEF. So we can write here as, by case 1, triangle ABC is congruent to triangle DEF. Congruent to triangle DEF. So this is the proof of this two triangles. Okay, now let's come on the third case. This is the third case. Now in this case we are taking points M on DE, okay, and in this case taking points on DE, taking point M on DE. Okay, now here is, in this case, if AB is less than DE, okay, then by choosing point M on DE such that AB is equals to ME, okay, then by choosing a point M on DE such that AB is equals to ME. What is AB is equals to ME? And now from this again and repeating the case second, repeating the case second, we get what? We get triangle ABC is congruent to triangle DEF. Okay, how we can prove this? By repeating the case number 2, because my dear friends, now we are proving this triangle ABC is congruent to triangle MEB by ASA rule, by side angle side rule, means we know that this side is equal, this angle is equal, and these corresponding sides are equal. So we can prove this by, yeah, we can prove it by the side angle side rule. And again by the simplicity we can say that this angle is equals to this angle. So but we know that angle ACB is equals to angle DFE. Okay, so this angle is not possible. It is only possible when M is coincide on point D. Okay, so from this we can prove that triangle ABC is congruent to triangle DEF. So I hope you understand these things, my dear friend. So this is the case of angle side angle. What is? Yes, angle side angle. Okay, now my dear friend, let's come on. Yes, here is now angle side criteria for congruency. Angle side criteria for congruency. Now this is the application of angle side angle rule. This is the application of angle side angle rule. Okay, so first of all, here is, my dear friends, angle side. This A is stand for angle side rule. Angle side rule. So when two angles and a non-included side of a triangle are equal to the corresponding angles and a side of another triangle, then the triangle are said to be congruent. Then the triangle are what? Then the triangle are said to be congruent. Okay, if you see in these two triangles, here is two angles, these corresponding angles are equal and one side is equal. Okay, so in this case this side is not between these two other corresponding angles. Okay, means this side, this AC is not, we are not taking the side included in these two angles. Okay, so this is a, here is a different length. So now double edge rule can be proved in easy steps. How we can prove this? Suppose we have two triangles ABC and DEF. Okay, now here is angle B is equals to angle E. Okay, this is what? This is corresponding angle, and angle C is equals to angle F. They are what? They are corresponding angles. They are corresponding angle, and AC is equals to DF. This is what? Adjacent side. Adjacent sides. So I hope you get this point, my dear friends. Okay, now here is, now by the angle sum property, by angle sum property, okay, we can write here as angle A plus angle B plus angle C is equals to what? 180 degree. Okay, and similarly angle D plus angle E plus angle F is equals to again 180 degree. Okay, by angle sum property. So this is equation 1 and this is equation 2. So now we can equate these two equations because RHS, both the RHS are same. So we can write here as, from equation 1 and 2, we can say that angle A plus angle B plus angle C is equals to angle D plus angle E plus angle F. Okay, so now here is, you can see that you can write angle B is equals to angle E, we know that. Okay, so we can write angle E in place of angle B and angle F in place of angle C. So here is, this will become angle A plus angle E plus angle F is equals to angle D plus angle E plus angle F. So from this angle E and this angle E will be cancelled, and this angle F and this angle F will be cancelled. So we get, my dear friends, here is angle A is equals to angle D. So now we have angle A is equals to angle D. Got it, my dear friend? So now in triangle ABC and triangle DEF, here is angle A is equals to angle D. This angle A is equals to angle D, okay, and AC is equals to DF, and we can write as also AC is equals to DF. AC is equals to what? AC is equals to DF, and you can see that this angle is also angle C is equals to angle F, because this is given part. So angle C is equals to angle F. So these two conditions are given. So now here is, we can say that triangle ABC is congruent to triangle DEF. By what? By angle side angle rule. By angle side angle rule. So I hope you understand this thing. So here is, we can prove that triangle ABC is congruent to triangle DEF by angle side angle. So with the help of this condition, we can prove these two triangles are congruent. Okay, so these conditions are what? Angle side angle. So this is what? Angle side angle rule. Got it, my dear friends? I hope you understand these things. So now let's move on. Yes, now why side angle or angle side and AAA congruency rule are not valid? Okay, we know that we have side angle side rule, okay, and angle side angle rule and angle side rule, but we don't have side angle or angle side, okay, angle congruency rule, okay, because these rules are not valid. Why these rules are not valid? Now side angle or angle side test is not valid test for congruency, as the angle is not included between the pair of equal angle, okay, my dear friend. And the AAA test means angle test also is not valid test, as even though two triangles can have all three same angles, but the side can be the different length. Okay, now you can see that we have these three angles ABC and DEF. If all these three angles are equal, but there is not sides are equal, means we can say that shape is similar but size is different. Here is size is different, but in congruency both shape and size should be equal. Okay, I hope you get this point. So this become a test for similarity AA rule. You will study about this similarity in the next classes. Okay, so I hope you understand these things, why SSA or ASS and AAA congruency rule are not valid. Okay, got it. Now first question is, AD and BC are equal perpendicular to a line segment AB. Okay, and we have to prove that, show that CD bisects AB. Here is, we have AD is equals to BC, which are equal perpendicular to a line segment AB, and we have to prove CD bisects AB. Means this CD bisect AB, means we have to prove OB is equals to OM. OB is equals to OM. Okay, so for proving this, first of all, here is, now in triangle AOD and triangle BOC. Okay, now here is angle A is equals to angle B. They are what? Perpendicular angle, mean they are right angles. They are 90 degree, they are perpendicular. Okay, and we can write they are perpendicular, and AD is equals to BC. So this is given. This is what? This is given. Okay, my dear friend. And here is this angle is equals to this angle because vertically opposite angle. So angle AOD is equals to angle BOC, vertically opposite angles. Okay, so we can say that triangle AOD is congruent to triangle BOC. By what? By double AS rule. Here is, you can see that this angle is equals to this angle, and this angle is equals to this angle, and this side is equals to this side. So here is angle side rule. Okay, angle side rule. Okay, got it, my dear friends. So now we can write here as AO is equals to OB by what? By the rule of CPCT, corresponding parts of congruent triangle. So AO is equals to OB. So we can say that thus CD bisects AB. We can write hence proof. Okay, I hope you understand these things, my dear friends. So now let's move on to the next question, which is, now L and M are two parallel lines intersected by another pair of parallel lines P and Q. Okay, now we have to prove triangle ABC. Triangle ABC is congruent to triangle CDA. Okay, so here is, we have this figure. Okay, and in this it is given that P is parallel to Q and L is parallel to M. Okay, okay, this is what this is given. This is given, and we have to prove triangle ABC. Triangle ABC is congruent to triangle CDA. Okay, so for proving this, in triangle ABC and triangle CDA. Okay, now here is first condition is angle. Here is angle BCA, means this angle. Okay, is equals to angle DAC, because they are what? They are, yes, alternate interior angles. And similarly angle BAC is equals to angle DCA. This is again what? This is again alternate interior angles, and we can write here as angle BCA is equals to angle DAC. Okay, is equals to, they are what? They are alternate interior angles. Again, angle BAC is equals to angle DCA. So this is what? This is again alternate interior angles. Alternate interior angles. Okay, and here is AC is equals to AC. This is what? This is common. This is common. So from this we can write here as triangle ABC is congruent to triangle CDA. By what? By, here is you can see that by angle side angle. Okay, here is angle side angle. Got it, my dear friend? Okay, now let's move on. Yes, so the next question is, line L is the bisector of an angle A. Okay, line L is the bisector of this angle, and B is any point on L. Okay, and BP and BQ are perpendicular from B to the arms of angle A. Okay, here is BP and BQ are perpendicular from B to the arms of angle A. Okay, means on this line, means at point Q and at point P. Now we have to prove triangle APB. Triangle APB is congruent to triangle AQB, and BP is equals to BQ, or B is equidistant from the arms of angle A. Okay, so now here is, it is given that the line L is the bisector of angle A. Okay, and the line segment BP and BQ are perpendicular drawn okay from the L. So here is we can write as, in triangle APB and triangle AQB. Okay, so angle P is equals to angle P, because they are right angle, they are 90 degree. Okay, and we know that AB is equals to AB. So this is what this is. Yes, this is common. And here is, you can observe this angle is equals to this angle, because line L is what? This is perpendicular, this is the bisector of angle A. So we can write here as angle BAP is equals to angle BAQ, because line L is what? Is the bisector of angle A. Okay, so triangle APB is congruent to triangle AQB. So I hope you understand these things, my dear friends. So by what? By double AS means angle side criteria. So you can see that here is one angle and here is another angle and the adjacent sides. Okay, and similarly here is one angle and the another angle and there is adjacent side. Okay, so these two triangles are what? These two triangles are congruent by angle side rule. So we can say that by the rule of CPCT we can write here as, this is the second part, BP is equals to BQ. BP is equals to BQ by what? By the rule of CPCT, because this is what? This is the corresponding parts. BP is equals to BQ. Got it, my dear friends? Okay, so and it can be said that point B is equidistant from the arm of angle A. Okay, so we can say that it can be said that the point B is equidistant here is equidistant from the arms of angle A. The arms of angle A. Okay, these arms, from these arms. I hope my dear friends you understand these things. So now let's move on. Yeah, so now my dear friends, so the next question is here is in figure AC is equals to AE. Here is AC equals to AE and AB is equals to AD. AB is equals to AD. Okay, and angle BAD means this angle is equals to angle EAC means this angle. Okay, and we have to prove BC is equals to DE means we have to prove BC is equals to DE. So for proving this we have to take triangle ABC and ADE. Okay, so let's start to solving this question. Now first of all here is, now it is given that in this AB is equals to AD and AC is equals to AE. Okay, and angle BAD is equals to angle EAC. So this is what, this is the given. This is the given and we have to prove BC is equals to DE. Okay, we have to prove this condition. Okay. So now here is, now let's start. So now we know that angle BAD is equals to angle EAC. Okay, now in this equation, now we have to add angle DAC in both the side. We have to add angle DAC means this angle. Okay, so here is angle BAD plus angle DAC. Got it? Is equals to angle EAC plus angle DAC. Now listen to me very carefully. Now if we add angle DAC in angle BAD, so this will become what? Angle BAC. This will become what? Angle BAC. Okay, and if we add angle DAC in angle EAC, so we get angle DAE. This will become angle DAE. So here is we get angle BAC equals to angle EAD equals to angle EAD. So I hope you get this point, my dear friends. Okay, so now let's consider the triangle. Now triangle ABC and triangle ADE means this triangle ABC and ADE. Okay, so in this triangle we know that AC is equals to AE. So this is, we know that this is given. This is given. AC is equals to AE. Okay, and also here is AB is equals to AD. Okay, so this triangle, if you separate these two triangles, so we get like this. So this triangle is similar. So this is A, B, C. Okay, this is A, D, E. Okay, here is we have AC is equals to AE and AB is equals to AD. Okay, and we already proved that angle BAC, this angle is equals to angle EAD means this angle. Okay, so this triangle we can prove congruent by what? By side angle side rule. By side angle side rule. So here is, we can write again AB is equals to AD. This is also given. This is also given, and angle BAC is equals to angle EAD. Okay, so here is, we can say that triangle ABC is congruent to triangle ADE by what? By which rule? By side angle side rule. By side angle side rule. So my dear friend, by the rule of CPCT we can say that BC is equals to DE. Here is, so we can say by CPCT. This is hands proof. So I hope you understand these things, my dear friends, how to deal with these type of questions. Okay. Yes. So now, so the next question is, now AB is a line segment. Here is AB is a line segment, and P is its midpoint. P is what? P is midpoint of AB. Now D and E are points on the same side of AB, such that angle BAD means this angle is equals to angle ABE, means this angle ABE, and angle EPM means this angle is equals to angle DPB means this angle. Okay, now we have to prove triangle DAP. This triangle DAP is congruent to triangle EBP. Okay, we have to prove these two triangles are congruent. Okay, and we have to also prove AD is equals to BE. Now if we prove these two triangles, so this is automatically equal by CPCT. Okay, now let's start to solve this question. Now here is, now we know that P is what? P is midpoint of AB. So we can write AP is equals to PB. Okay, we can write it. Now here is, my dear friends, let's start to solve the first part. Okay, now in this we know that angle EPA is equals to angle DPB, means this angle. EPA means this angle is equals to angle DPB. Okay, now if we add EPD in both the angle, then this will become, now add angle DPE. Okay, so this will become, here is angle DPE on both sides. So this will become angle EPA plus angle DPE. Okay, got it. This is equals to angle DPB plus angle DPE. Okay, so now here is, if we add angle DPE in angle EPA, so this will become what? This will become angle DPA. This will become angle DPA, means this angle. Okay, and if we add angle DPE in angle DPB, so this will become what? This will become angle EPB, means this angle, this complete angle. Okay, so we get, my dear friends, here is, this will become angle DPA is equals to angle EPB. Got it, my dear friends? I hope you get this point, EPB. So now let's consider triangle. Now in triangle DAP and triangle EBP. Okay, here is, now in triangle DAP and triangle EBP. Okay, we are doing this separate this triangle. Okay, now this triangle is look like, this triangle is similar to like this. This is ADP. Okay, and we have another triangle is what? This is EPB. Now here you can see that angle DPA is equals to angle EPB. We prove this. Here is DP and EPB, and here is AP is equals to PB. AP is equals to PB. This is by the midpoint term. Okay, we know that P is what? P is the midpoint of AB, so we can write AP is equals to PB. And angle DAP is equals to angle EBP. This is given part. This is what? Yes, this is given part. Okay, so we can say that triangle DAP and triangle EPB are what? DAP and EBP is what? Are congruent by what? By angle side angle. Angle side angle. Okay, so now let's write these conditions here. So here is angle DPA is equals to angle EPB from above condition. Okay, and we know that AP is equals to BP. Okay, because P is midpoint of AB line segment. Okay, and here is also one condition is there, angle BAD is equals to angle ABE. So this is given. This is what? This is given. Okay, so we can say that triangle DAP is congruent to triangle EBP by what? By angle side angle rule. By angle side angle rule. Okay, now if we come on the second part, though we have to prove AD is equals to BE, means AD is equals to BE. So this is already proved by what? By CPCT. So we can say that AD is equals to BE by CPCT rule. By CPCT rule. So I hope you understand these things, my dear friends. Okay, so now my dear friends, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.